Okay, guys, so we are back again with the next lesson, and we've been doing a lot with angles and arcs, and now we're going to create relationships that pull in chords. So we know what chords are. Um, let's just jump into it. A chord we know is a segment that lives inside of a circle with both endpoints on the circle. Now, as we move forward, we want to understand a few things. So let's highlight a few things that are really important for us to keep track of. So first of all, two circles are congruent if their radii are congruent. So looking at this figure here, if the radii of the two different circles, so plural, if the radii of the two different circles are congruent, then those circles are congruent. So for example, if one was called A and B, we could say circle A is congruent to circle B. Now, that means that their radius or radii are congruent, their diameters, their circumference, right, the distance around the circle, and their area. Everything about those two circles are identical. So those two, if any of these are congruent, then the circles are congruent. In the next example, we have what we call concentric circles. So concentric really just means that they share the center. So in this circle, you can see that the two circles share the center, but they definitely have different radius. So we have the small circle radius, and then of course we have the larger circle's radius. And they're not equal. So these circles are not congruent. They're just concentric. Now, something that we want to notice about concentric circles. So we just took our same example from the previous slide. We have two circles, a smaller circle and a bigger circle. They share the center called A. So we would have to be really careful if we said, look at circle A, we wouldn't know which one we're talking about. So we'd have to be a little bit more clear in our discussion. But we want to notice a few things. First of all, the radii are not congruent. So the circles are not congruent. However, it is really important for us to recognize that angle A from the little circle and angle A from the big circle are the same angle. They definitely are congruent. So angle BAC in the little circle and angle DAE from the big circle are congruent. They are equal in measurement, and they are both central angles. Now let's keep in mind what that means to us. For example, if we said that this was an 80-degree angle, then BC is an 80-degree arc, and DE is also an 80-degree arc. So the arcs are equal in measurement. All right, that's kind of important here. The arcs are equal in measurement, in degrees. Now, we're not saying that they're the same length. It definitely is a longer arc from D to E than it is from B to C. So again, we are not saying that they have equal length, but they are equal in measurement when it comes to degrees. The length of an arc, that's part of the circumference. That's coming soon. Right now, we're still working with measurement of arcs in degrees. So we have to be really careful. It can be confusing. We have to be really attentive. Okay, so let's get into our three rules, and there's only three of them that relate angles and chords. So first we can see, we can say here that if two chords are congruent if they are equal distance from the center. So two chords are congruent if they are equidistant from the center. And we're always going to look at a perpendicular distance. So looking at our examples, since the distance to chord DC is the same as the distance to chord AB, we can say that AB is congruent to CD, or the measurement of AB is equal to the measurement of CD. And remember this magic clause here, if and only if. What that means is that we can say it the other way. So if two chords are the same distance from the center, then the chords are congruent. Or if two chords are congruent, then they are the same distance from the center. And again, this is specific to being in one circle or identical congruent circles. If we had a big circle and a small circle, all bets are off. So again, we said that there were three rules. The first one, two chords that are the same distance from the center are congruent. Second, if two chords are congruent, so for example, CD and AB, if those chords are congruent, then the arcs that they sliced off are also congruent. So if the chords are congruent, then their arcs are congruent. And we can reverse that by saying if the arcs are congruent, then the chords that slice them off are congruent. So again, just like we want to match the angle with the arc, we want to match the chord with its arc, its intercepted, its arc. Okay. Third rule, and this is going to come into play a lot. If the diameter or the radius, because that's really part of a diameter, if it is perpendicular to the chord, then we bisected the chord and we bisected its arc. So if we have, for example, diameter BA is perpendicular to chord DC, well then we bisected the chord and we bisected its arc. Now this is going to be really important because as soon as we have a right angle, you can be sure that we're going to have right triangles. So that means we're going to have to use things like Pythagorean theorem and trig. So that's pretty important. Those things are going to come into play. Now, if you look at this triangle carefully, and I'm going to just take this triangle and I'm going to pull it out here. There are three parts to that triangle: the radius, the distance from the center to the chord, and the chord. Really, it's half the chord. So keep that in mind. We want to see right triangles. We want to see right angles. Those are the things that are going to help us solve problems. So the parts that go into that triangle, and it's always going to be the same thing: the distance from the center to the chord, that's where we get the right angle with the chord. And since we're only using one side of it, we're going to close it off with the radius. So we're going to do a few practice problems, and I'm going to split this into 2 days. Most of the right triangle stuff is going to be day 2. So let's get a basic understanding here for day 1. Let's do a few practice problems. So we're not going to do them all, but I'm going to pick a few to try. So something like number 1, we're looking for the length of segment AB. Well, since the arcs are congruent, then those chords have to be congruent, which means it's simply 9. Let's look at number 3. Here's our chord. That chord is 8. So LJ is 8. And look at its arc. It's the arc marked 1 plus JM. Well, here we have another arc cut off by a chord. And again, it's an arc marked 1 plus JM. So since the arcs are congruent, arc labeled 1 hash mark plus JM, then those chords have to be congruent. So we get another 8. So it's the picture, not the math, that can make things a little bit more challenging. In the next few examples, we're going to switch it around a little bit. Now we know about the chords, but we're being asked about the arcs. So let's just pick a few and see how it goes. Let's take a look at number 5. We're looking for the measurement of arc TU. So here's arc TU, and here's its chord. Well, notice that that chord is congruent to this one. So if the chords are congruent, then their arcs are congruent. So really the question is, if we know arc SR, then we know arc TU. Well, what's arc SR? We have to use our old knowledge of our central angle. Angle at the center equals arc. So 85 degrees. So then TU is also 85 degrees. So we're just piecing this together from our knowledge. Okay. We're using the same rules. Chords equal distance from the center are congruent. If the chords are congruent, the arcs are congruent. And if the diameter or part of it is perpendicular to the chord, it bisects the chord and its arc. Let's take a look at another example here. We're asked to tell whether these things are equal. So let's see what's going on here. LK and KN. So LK is right here, and KN is right there. And we're being asked, are these things equal? Well, look at MP. It is perpendicular. And we have a rule that says if the diameter is perpendicular to the chord, then it bisects the chord. The question here is MP really a diameter? So we have to be able to answer that. We have to ask ourselves that. Is MP a diameter? And, well, I don't know. Because we don't know where the center of the circle is. It looks it, but we really don't know. So we're going to have to say no. If you look at number 11, SU definitely is a diameter. Notice it goes right through the center. Now the question is SU perpendicular to TR? If the diameter is perpendicular to the chord, then it bisects the chord and the arc. But is it perpendicular? Again, looking at our picture, we're forced to say, I don't know, which means our answer has to be no. There's nothing there that says it's perpendicular. So that's how I want you to think about it. And you can do number 12. Let's go a couple more problems here. So I'm just going to blow this up because there's a little more going on in these pictures, but that doesn't mean it's that tough. Let's see. We're asked to find BD. So we're going to find BD. Now let's use our previous discussion. We do have a diameter. It is perpendicular to the chord, which means it bisects the chord. So we have 5 and 5, making BD 10. And we're going to use that same exact thought process, that same exact reasoning in number 14. we're looking for JK, the arc JK. Well, this one is 55. So again, in 14, we have a diameter perpendicular to the chord, so it bisects the chord and the arc. So we have 55 degrees. Number 15, we're going to use the same thought process and add one little step. So using our explanation from 14, we have a diameter perpendicular to a chord, which means that we bisected the arc. So that's great. It's just not what we're actually looking for. In this question, we're looking for arc MN. Well, this is going to come back to an older question. Look at arc MNL. That's 180. So what we're going to have to do is 180 minus the 61, leaving us, what do we get? Leaving us 119. So we've seen plenty of questions where we had a semicircle. We knew one arc, find the other arc. Now we just added the step. We had to find the first arc by knowing the new rule. The diameter is perpendicular to the chord, so it bisects the chord and its arc. Okay, let's see what else we have in our next slide here. Tell whether the lengths are equal. So CD and EF. CD and EF. Since they are equal distance from the center, then the chords are congruent. So that's a yes. In 17, look at these two numbers, 8 and 9. Those chords are not the same distance from the center, which means the chords are not the same length. Remember, if two chords are equal distance from the center, then they are congruent. These are not equal distance. Lost my pen there. So not congruent. So no. And in number 18, notice that the angles are not congruent. One of them is measured perpendicular. The other one is 88 degrees. We have to have equal distance measured perpendicularly. So that's also a no. And let's see what we have left here. A couple more questions. We're not going to go too crazy here. It's all the same concepts. So again, just picking a few questions to take a quick look at. The first row, 19, 20, 21, they're exactly the same as what we just did. 20, 22, 23, the bottom row, we just pull in a little bit of algebra. So let's just talk about the setup here because we're not going to go nuts. You can solve this on your own. In the first one, we have a diameter perpendicular to a chord. So I'm on 22 here. We have a diameter perpendicular to a chord. So it bisects the chord. So that means 6x plus 1 is equal to 8x minus 5. We bisected the chord. In number 23, we have arcs that are congruent, which means we have chords that are congruent. So if we compare the two arcs as congruent, then those two chords are also congruent. So that's going to give us our formula here. So we have 4x minus 1 equals 3x plus 6. And then finally, we have the same reasoning in number 24. Since the chords are equal distance from the center, then the chords are congruent. And since the chords are congruent, then the arcs are congruent. So we're just pairing two of those rules. Since the chords are the same distance from the center, then those chords are congruent. Now, since the chords are congruent, then their arcs are congruent. And that's going to give us our formula. So here we have 31x is equal to 35x minus 16. And of course, we're going to solve for x from there. Okay. All right, guys. So like I told you, today our focus was on the 3 rules being applied. Tomorrow, we're going to bring in the idea, and I'm just going to scroll back to it quick. Tomorrow, we're going to bring in the idea. Not only did the diameter bisect the chord and its arc, but now we can use the perpendicular segments, or use the right angle to form right triangles. So we're going to see that in tomorrow's work. All right. Today focuses on the 3 rules, and then we'll apply it a little bit more tomorrow in more depth. All right, guys, that's it for this lesson. Work on the practice problems, and I will talk to you all soon.